Here we go. Pretty big day here today, all right? Going to learn a new mathematical concept. Your whole mathematical careers. When somebody has asked you, what is the measure of this angle, you respond. You can measure an angle, okay? It is called a radian, all right? Also, if you remember 2 units ago, we start every day with make sure you're in what mode on your calculator? Degree mode. And if you ever notice, there's one right next to it too, which is radian mode. And we're never going to be in radian mode, right? You can be in that next year in algebra 2. All right, we're never still good, but that's why it's next there. That's another way you can measure an angle, is in radian measure. And you're going to figure out what a radian is today and how to go back and forth between degrees and radians. First thing I want to just cover real quickly, circumference formula. C equals 2 pi r. And where did it come from? Okay, why is it 2 pi r and not anything else? What's the r stand for? Radius. All right, you're going to find out why right now on that piece of paper with the string and your compass. So here's what I need you to do. Whoever has that compass and is the best in their group at using it, what you're going to do right now is you are going to make a full circle, hopefully pretty detailed, not shaky. That's why you're the best, right? Okay, so put your compass point somewhere on your paper. Can somebody please take a pen or pencil and put the center point wherever their point on their compass is? Somebody else in the group right now, or that person, all right, please put your center point right now where you're putting your compass point. So we know that's the center of the circle. And draw yourself a circle. Doesn't matter. Doesn't matter. Stay on the paper. Okay, every group's got a circle. We're getting there. What I'd like you to do, so the same person or somebody else in the group wants to contribute, put a point on the circle somewhere. Put a point somewhere on the circle. On the circle. On the circle. On the circle, everybody. Okay, take a straight edge. Connect your center and that point, and you've constructed a what? A radius. Perfect. No. And what I'd like you to do right now is take that piece of string I have given you and make a radius from your circle. So scissors will be coming around. You're going to line up a piece of string on your center and on your point on the circle. And I'd like a piece of string that is the same length as your radius right now. Please be as precise as possible when you cut it. There are scissors going around here. If you have your own, you can use them. Just leave it out there. I'll get it. See you later. All right, what do we find out? 6 exactly? No. It wasn't 6 exactly. It was what? 6 and a little bit more of your radius, right? Not the full one, but a little bit more. Everyone agrees? It was about 6 and a little more. And you went all the way around the circle. So what did you end up measuring all the way around the circle? What's that distance called? Circumference. So you found out the circumference was equal to, not mathematical at all, 6 and a little more radii, right? That's what you guys just found out, right? Grab your calculators that you have in front of you. What is the circumference version of the one that involves radius? Formula that involves radii. 2 pi r. Everyone right now type 2 pi in your calculator and see that decimal. What did you find out? It's 6 and a little more. Okay, 6 and change, as we like to say. All right, 6 and a little more. So that's where that comes from. All right, any circle, you can fit 6 and a little more radii around it. Okay, which comes to our first conversion here. And it's already on your paper. How many degrees all the way in the circle? 360. All right. Let me describe first what a radian is. So now everyone take your piece of paper right now. And what I'd like you to do is draw in an angle where the radii and your arc length are the same length. All right. So radii, and then you're going to measure from one point on the circle to another, put that point, and make that angle in, please. Okay? So your radii and your arc length, should be the same length. Everyone see that central angle that you've just formed? That is 1 radian measure. Okay? When your radius and your arc length match, that is the definition of 1 radian measure. How many of those could you fit on your circle? 6 and a little more. In degrees, if you went all the way around, how many degrees is it? 360. But in radians, 2 pi. Okay? So there's 360 degrees in a circle, and there's also 2 pi radians in a circle. 360 is equal to 2 pi in radians. All right? Here's what I need you the ability to do now. Okay, you know 360 in radians is 2 pi. What about 30 degrees now? What about 45 degrees? What about 60 degrees? 90 in radians. How do I convert those? Everyone go to the back of your packet, please. You will see a good friend we haven't seen in a while. Your formula sheet. Okay, everyone see your formula sheet. Do you see in the second column, you have one for radians and one for degrees? Well, I'm trying to go from degrees to radians. So everyone see where it says degrees? What's 1 degree equal to? Pi over 180 radians. So to change degrees to radians, I multiply by that conversion on the formula sheet, which is, what 1 degree equals? Multiply by pi over 180 if I want to change any degrees into radians. Okay? If that's on your formula sheet, no need to memorize. You just got to locate it on your formula sheet. All right, so let's go through some of these quickly. I don't think we'll do all of them here. 30 degrees into radians. So ready? You take 30, multiply it by pi over 180. But here's the thing. You want it to be exact as possible. So you're going to leave the pi in your answer when you leave the radians. Okay? Notice we didn't write 6 and change, right? Radians. We wrote 2 pi radians. Same thing here. Leave your radians in terms of pi. I would like you, though, to reduce 30 over 180. Okay, reduce that fraction for me. 30 over 180, anybody have that reduced? 1 over 6 or pi over 6. Okay? That's more exact than doing whatever 3.14 divided by 6 is to leave it like that. So 30 degrees is the same as pi over 6 radians. All right, what about 45? Pi over 180. Again, leave the pi in your answer so we have some exactness to it. And 45 divided by 180. And we have pi over 4. If you guys want to go ahead and quickly do 3 and 4, go ahead. Take 60 and 90 and convert them for me. $60 degrees, what is it in radians? 15, 60 degrees, what is it in radians? Pi over 3, nice job. Pi over 3, what about 90 degrees? Here you go, 17, how about 90 degrees? Pi over 2. Okay, so here's what we got to multiply by to go from degrees to radians. What if I don't want to go in reverse? I have some radians, and I need to be put in degrees. Go ahead, go back to your formula sheet. It's on there. But now I want to start with radians. Now I'm starting with radians. So I no longer want to multiply by pi over 180. I want to multiply by 180 over pi, and you guys are going to see very quickly why I want to do that. So now I want to multiply by 180 over pi. So everyone ready? 7 pi over 6, that's in radians. What's its equivalent in degrees? Multiply by 180 over pi. Anybody see right now why I want to multiply by 180 over pi? What's going to cancel? Pi's are gone. Yep. So all I need to do is 7 times 180 and divide that sucker by 6. And how many degrees am I looking at here? 210 degrees. All right, let's go through the others. 3 pi over 5. Pi's cancel out. And 3 pi over 5 in degrees. What are we looking for? 20? 108 degrees. And 5 pi over 3. $28 here. One job. 24. 23. 300. And then we get to number 8, which is take 3 radians and put it in degrees. Now, I don't know if anybody's freaking. It doesn't have a pi with it. It can't be radians. Baloney. Guys, we put a pi with it so it's more exact. If you do 3 pi divided by 5, you're going to get a long sloppy decimal. That's still in radians. Okay, we just put the pi with it to make it a little cleaner and exact. You can have it without the pi. What am I still going to multiply 3 by if it's in radians and I need degrees? 180 over, okay, 180 over pi. But guess what? Pi's not going to cancel out. And this drives me nuts. Do you see an equal sign between there? No, so there, I don't know why cross multiplication comes up. It's just 3 times 180 divided by pi. And you guys can round it to the nearest tenth of a degree for me right now. So it's okay if it doesn't have pi in there. We just put pi in the radians to make it a little cleaner and exact. 171.9. Tomorrow on the video, I'm gonna introduce a new arc length formula that you need radians for. So that's why I'm showing you how to convert back and forth. All right, I will check all the homework on Monday. Please check the answers on Aspen. All string and paper can be recycled.